Welcome. In this video, we're going to use the Bernoulli distribution to model the flip of a bias coin. The Bernoulli distribution can be used to model a situation when there are only two outcomes, success or failure. We've used 0 to represent failure and 1 to represent success. So let's use the Bernoulli distribution to model the flip of a bias coin. That's a coin that normally a fair coin you'd expect to get as many heads as many tails, or put another way, you expect the probability of heads to be equal to the probability of tails. With a bias coin, we're going to have a greater probability for heads than for tails, because we're going to consider heads as a success. So we create our vector with two numbers, 0, 1, representing our sample space, and then we'll create a probabilities using the dburn function. We pass that to x with a probability of 0.6. So we're going to say the probability of heads is 0.6. Now when we plot that, we see we have this. Probability of tails is 0.4. The probability of heads is 0.6. Yeah. So there's our plot there, and our plot there. So you can find the probability of obtaining a heads using this function called dburn. 1 is probability of this outcome ahead, representing the head, and we've already said the probability of head is 0.6. So of course, we're not surprised when the answer is 0.6. We can also look at the probability of obtaining tails. So a tail is represented by 0. So dburn 0 is 0.6 will give us probability of tails, which is of course 0.4. Now we can look at the probability of obtaining heads or tails. Well, that would be p burn, so the probability of getting at least 1, so we're getting at least a head, is probability of getting heads plus probability of tails, so of course we get 1. But we could have figured that out there. And finally, we can flip the coin 5 times using the command rburn, and then 10, and then again pass the parameter 0.6. And we do that, we will get this outcome. This is one of many outcomes. When you run this, of course, you can get something completely different. But here we've got, so what happens is we've got a heads, the tails, the heads, and tails, heads, tails, heads, heads, tails, heads. So we've got 1, 2, 3, 4, 5 heads. But we would expect in 10 flips to get 6 heads. So that's not too bad. So that's how we can use the Bernoulli distribution to model the flip of a bias coin in R. As an exercise, why don't you try using the Bernoulli distribution to model the flip of a fair coin? Thanks for watching.